So, we're going to learn where carboxylic acids and esters are relevant to health and in the human body. First, we're just going to look at a bunch of examples and try to really pick out the carboxylic acid and ester functional groups. So, let's just review what those are in general. The carboxylic acid functional group has some sort of R or alkyl group, like a carbon chain, bonded to a C that's double bonded to an O, and that C is bonded to an O and then an H. And again, R is your alkyl or, just your carbons, your alkyl group, your carbons, continuing in that direction. What are esters again? Esters have an R and they have a C double bonded to an O, and then they have an O and it's bonded to what we call R or R prime. So it could be that these R and R prime are matching groups. They could be two different groups in an ester. But in an ester, the carbon chain continues in both directions from that ester functional group. Okay, so let's check out this first one. We've got CH3, C double bonded to an O, and that C is bonded to an OH. So that's a carboxylic acid. Let's abbreviate the carboxylic acids with a Ca. I just think that's going to be a lot easier. If we find esters, we could put E for now. I think Ca, like California, is going to be easier for our carboxylic acids. So this one we're going to label right away. Ca, that's a carboxylic acid. But actually, we want to recognize that carboxylic acid. This is a special one. Take a second to remember, if you will. This one's acetic acid. Okay, so we want to actually recognize this specific carboxylic acid when the R group is CH3, that it is acetic acid. Okay, let's look at the next molecule. Oh, it's a long one. CH3, CH2, CH double bonded to a CH, CH2, CH double bonded to a CH, CH2, CH double bonded to a CH. Then there's CH2 so there's 7 CH2 groups in there. And then there's a C double bonded to an O that's bonded to an OH. So at the end of the chain, we recognize that C double bond O and that OH are our carboxylic acid. And so this is actually a fatty acid because it's got this long carbon chain. That's the fat portion of the molecule. And then it's got this carboxylic acid portion of the molecule at the end with this acidic hydrogen. So this is where we get fats from when we study the human body, we're studying triglycerides of these fatty acids. Oh, speaking of that, that's what's up next. Here, what's up next is actually a triglyceride. And this is when we have 3 of these fatty acid side chains on a glycerol backbone. So I'm getting a little ahead of myself, but I can't help it because I end up referring to these glycerol backbones before. What's the glycerol backbone? Well, that's where these 3 carbons in a row kind of going down the glycerol chain. Glycerol itself is CH2, CH, CH3, and you'll notice we're short bonds here. We need to put an OH on each carbon of that chain. So it's 3 carbons in a row that each have an OH on them. That made the backbone of this molecule. Now, if you envision that, I'm just going to kind of draw it goes up here. If you envision that backbone of the molecule with 3 fatty acid chains, just like the long ones we talked about above, 3 long carbon and hydrogen chains off of each of the OHs in glycerol, that OH gets replaced, and look at this. We've got a different functional group here. Sure enough, on the first CH2 of the glycerol backbone, it's bonded to an O, that's bonded to a C, that's double bonded to an O, and then the carbon chain continues, though, with CH2, 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 and it just continues. And so because we have this OC double bond O sandwiched in with carbons in either direction, that is an ester. So I think I'll do these esters now with this blue, but that's an ester functional group there. If we kind of study, I don't think we have any more esters on our current screen, so I better switch back to red. And we'll look for some more carboxylic acids. In our next molecule down here, we've got what we recognize as a benzene ring. Okay, and then that benzene looks like benzoic acid because it's got a C double bond O and an OH. So we'll mark that Ca for a carboxylic acid. Oh, and then thankfully I was wrong. Look at what's down here. We have a C double bonded to an O, bonded to the O that's bonded to the benzene ring, but in the other direction there's a CH3. So again, the benzene ring's connected to an O that's connected to a C, double bonded to an O. And then that C is connected to a CH3. So here the carbon chain continues in both directions. So that is an ester. And let's look at some of our next functional groups. So if we look at this next big molecule, let's just focus on plucking out functional groups. Like when we see our hexagon with alternating double and single bonds, that's our benzene. What else can we find here? Well, we see a lot of nitrogens. When we see nitrogens, those are generally amines. We want to get good at picking out these amines. So these nitrogens that are connected to some carbons are amines. We'll study them in a little bit more depth shortly, where we can figure out exactly if they're primary or secondary or tertiary. Spoiler alert, it's pretty much just like alcohols. There is one little trick here. A couple of these might look like regular amines, but actually, when the nitrogen is connected to a carbon that is double bonded to an oxygen, nitrogen's connected to a carbon that's double bonded to an oxygen, technically that's an amide or an amide. I have to say them differently, but amide right there. Now, we've got a couple of our favorites here, though. We see that the zigzag carbon chain has the end of its zigzag being double bonded to an O and then connected to an OH. And another one, C double bonded to an O and connected to an OH. So when we see those are both carboxylic acids. So even if the structure's big and complicated and we can't quite really describe it all or begin to wrap our minds around it, it seems at first, look for what we're familiar with. Look for the benzene rings, those hexagons and their alternating single and double bonds. Look for carbons at the end of the chain that are double bonded to O and then bonded to OH, carboxylic acids. Look for nitrogens that are bonded to some carbons, usually amines. And so that's how we kind of pick things out. Oh, and of course, picking out our esters is our C double bond O bonded to our O with then the carbon chain continuing in either direction.